Welcome back, Calculus. Our objective for today is going to be to evaluate higher order derivatives and apply them to motion problems. I'm going to force a pause on your screen, make sure you've got everything on the checklist, make sure you're in full screen. All right, so today we're going to look at kind of what I've got on the screen here. When you've got F with 2 tick marks beside it, what do you think that represents? What do you think this means? So this is called the second derivative. And this is the derivative of, man, I really can't spell that today, of the derivative. Okay, not surprisingly, goodness, if I have F with 3 tick marks, that is F triple prime, okay? So that would be the derivative of the derivative of the derivative, okay? So we can just keep taking derivatives and we denote them like so. You can probably see that after about 3, it starts to get hard to read how many tick marks you have there. So after 3, instead of a tick mark, we usually do parentheses with that number. So if I want like the 4th derivative, you'll typically see parentheses, let me zoom in here, you'll typically see parentheses 4, okay? So if I want the 7th derivative, you could have like F parentheses 7 as a superscript of X. So that's your prime notation. You'll notice we also have Leibniz notation, and this notation can kind of look a little bit weird at first glance. So like here, I have the 2 with the D in the numerator, but then with the X in the denominator. And that's because we read it as the second derivative of Y with respect to X, okay? So in the numerator, I'm putting the 2, I'm not going to call that a square, but I'm putting the 2 with the D, and in the denominator, I'm putting the 2 with the X, okay? You don't have to use this notation, you just have to know when you see that, okay, that means the second derivative, all right? And similarly here, that would be the 4th derivative. This would be the nth derivative, okay? So I'm going to force a pause on your screen. You can write down what you feel like you need to write down with this notation, and then we're going to try an example together. All right, example 1, I'm going to force another pause on your screen. Will you please copy what I have, and then we'll do this together. So it says find the 7th derivative of f if f of x is 3x squared minus 8. All right, and we just have to start with the first and keep going. So the first derivative, f prime of x, is going to be 6x. Derivative of 8 is 0, right? Constant goes away. The second derivative is going to be 6. Now what's the third derivative going to be? That's going to be 0, right? And then after that, the derivative, so the 4th derivative will be 0, and it's just going to keep going, right? The derivative of 0 is 0. So my answer is that the 7th derivative of f with respect to x is 0. All right? Now I want you to notice something. What was the first instance? What was the first time our derivative was 0? It was when we took the 3rd derivative, correct? And why do we think that was? Well, take a look at the degree of f of your original function. It was a 2, right? So once your derivative, like your 3rd derivative, is more than the degree of your polynomial, your original function, then your answer is going to be 0, okay? So let's put that in words. So let's write this together. If the derivative is more than the function's what? Degree, the answer is 0. So for example, again, the 3rd derivative, 3, is more than the degree here, 2. So after that, my answer is always 0. So starting with 3 and forward, my answer would have been 0. All right, so when we're discussing motion, that's really when higher order derivatives come into play. And there are 3 closely related concepts. We're going to put them in our table here, but first I'm going to force a pause on your screen. I'll move this up a bit so you can see it. Force Press on your screen, can you please copy the table and then we'll fill it in together. All right, so our three related concepts are position, and maybe this will, if you've taken physics, this will very much come in handy. Position, velocity, and acceleration. Okay, so for position, we often use S of t, or, and my students hate this, but x of t, because you're typically moving, you're only ever moving in Calc 1 in one dimension, okay? So one direction, and that is typically what we say along the x-axis, so horizontal movement. So it's not uncommon to actually see your dependent variable be your x, and then your independent is your time, okay? Example of units. That would be like meters, or miles, or feet, or some unit of distance. For velocity, we typically denote it as v of t. And velocity is actually the rate of change of position. So this is equivalent, I'm going to use s. This is equivalent to s prime, the first derivative of position. Examples of units here would be like meters per second, miles per hour, which typically we write like that, okay? All right, and then acceleration, the function notation is typically a of t. This is equal to the derivative of velocity, which is the second derivative of what? Of position. Okay, and here you would have like meters per second, and we typically write that as meters per second squared, which is, it works algebraically, but it's like, what are we talking about, squaring a second? But because you've got meters per second, we will often write that as meters per second squared, but either notation for the units there is fine. All right, so let's go a little bit more in depth with each of these three concepts. Would you please write just the word position in your notes? So let's define position. Position is where the particle, we typically talk about a particle moving, so where the particle is at any time. Okay, so what do I mean by that? Well, if I use x, so if my position at time 4 is negative 10, then, again, if I'm traveling along just the x-axis, here's 0, the origin, that means that after 4 seconds, my little particle is right there. Okay, so when time is 4, my particle is at negative 10 on the x-axis. Okay, it's glued to the x-axis. It cannot move up or down. It's just moving in one dimension. Okay, so that's position, where we are at any given time. Let me move down here. Okay, all right. So now can you write velocity in your notes for me? So for velocity, and again, my physics people will know this, this gives speed and direction. So let's write that. Again, at any time t, okay? So if my velocity at time 4 is negative 10, that means at t equals 4, I'm going to put some units on here, seconds, let's say, the particle's speed is 10 feet per second. Again, I'm adding units. And the particle is moving which way, do you think? It's moving left. Why? because your velocity is negative 10, okay? So the absolute value of your velocity tells you your speed, and then the sign tells you direction, left or right. Okay, so let's try, will you please write in your notes next, you guessed it, acceleration. So acceleration is going to give you how fast your velocity is changing. So if a of 4 is negative 10, this means at t equals 4 seconds, the particle's velocity is decreasing, right, because of the negative 10, at a rate of 10 feet per second every second. Okay, so it's losing another 10 feet per second of its velocity every second. Okay, and again, we can write that as 10 feet per second squared. Notice I don't have a negative here because of the word decreasing. All right. All right, so just some nerdy trivia for you here. I'm going to always start with my, if I consider like my f of x function to be position, and then I start taking higher order derivatives. So the derivative of position is what? Is velocity. What's the derivative of velocity? Acceleration. Okay, the derivative of acceleration, if you slam on your brakes really quick when you're driving, your body is going to make kind of a jerking motion, right? The derivative of acceleration is called jerk. Center that. Derivative of jerk is snap. Derivative of snap is crackle. Couldn't make it up if I tried, I'm dead serious. And derivative of crackle is pop. Okay, so those are, you will never see that on the AP exam. Those are derivatives, so first, second, third, fourth, fifth, and sixth derivatives of position. All right, you all, that is all for today. I will see you next time.